All right, it's time to have more fun with amateur radio. Hey, we're going to talk about data modes a little more today, specifically a program called Direwolf, which runs on Windows or Linux, and it's kind of like the ultimate sound modem for your amateur radio. So if you're into radio and data modes, email, texting, or just talking over any kind of data mode, you're probably going to run into Direwolf at some point. It's really the foundation for APRS packet radio, AX.25. It implements that transport layer. But Direwolf is epic in scale. I mean, just the manual is hundreds of pages. I kind of want to do a Direwolf for Dummies video or deciphering Direwolf. I wasn't sure what to call this video. But anyways, I just wanted to go over maybe a Direwolf.conf file that would let you implement an APRS Digipeater. That's just one use for Direwolf, and it's probably one of the most common uses. So let's do an APRS Digipeater with Direwolf. We've got the DigiPi here and a small. I'm gonna make myself a little smaller here. You guys don't want to see. So the DigiPi is a Raspberry Pi. It's actually running Direwolf at this very moment, and you can get more info on the DigiPi at Krager.org/DigiPi. This is a kind of a community project where you can get the image that runs on all Raspberry Pis and runs all kinds of digital modes. And of course, the digital homepage, digital DigiPi homepage is this guy, where you can see all the services that it implements. So right now it is in APRS. Let me do a refresh here and see what mode it's in. I think it's in TNC, but it's just obnoxious. I can turn the volume down. So right now it's an APRS TNC, which means I can connect it with the cell phone, interact, send and receive packets and messages to other radios. But for the sake of this program, we're going to turn this into an APRS Digipeater. So I'm going to press on right there, and you can see the DigiPi is now an APRS Digipeater. I don't know, it's kind of under my image here. And as the packets roll in, we'll see those stations, and it's going to repeat packets based on the packet criteria. So what's in the routing table. Is this something it should repeat to the rest of the network? Should it ignore it, or maybe it should just forward it onto the internet, kind of as an iGate? So it'll do all of those things at once. And yeah, I just transmitted its birth cry there to my radio. I'm sure that was loud. I got a little HT going on here. Well, we can maybe use this for the demonstration. So let's talk about how to configure Direwolf as a digipeater. All right, so we're on the DigiPi. It has Direwolf pre-configured as a digipeater. Now, by default, if you're using the stock DigiPi image, it won't repeat all the traffic it hears on the air. I just didn't want to enable that by default. I didn't want to burn up your radio or trash your airwaves. So when you download DigiPi, by default, it will simply repeat traffic from your call sign, because you configure your call sign in the DigiPi. And it'll also forward messages from the internet, like text messages that originate on the internet, and send those out to RF if there is a radio nearby, the target radio is nearby for that text message. So that's all the DigiPi does by default. It's not a full-blown digipeater. But if you want to make it a digipeater, let's do that. Let's look at Direwolf.conf. So on the DigiPi, we can open a shell. By the way, this is the new release candidate image for DigiPi. This is version 1.6, release candidate 3. We've got a Google group about it, so we're testing it right now, but I think it's pretty solid. This is the one we're going to go with for 1.6 with only some modest changes. So DigiPi 1.6, we're going to click on shell, and we're going to which opens a command prompt on the DigiPi. We're going to get into cool nuts and bolts stuff. Normally you wouldn't have to do this, but if you really want to hack on your DigiPi, this is what we're going to do. We're going to log in as a Pi user. The default password for all Raspberry Pis is raspberry, and this one's no exception right now. And so we got a command prompt on our DigiPi. I'm going to do an ls asterisk USB.conf. So this is all the Direwolf conf files for USB radios. As a matter of fact, speaking of USB radios, we've got the ICOM 705 right here. I was able to get this used at a pretty good deal. So there's the 705. It's tuned to an APRS frequency. And these are the different direwolf.conf files. So when you run direwolf, it's going to wake up and look for its conf file, and then that basically tells it how to operate. So in this case, we want to edit the direwolf.digipeater.usb.conf file because we're going to do some digipeating. I actually need to pull it into an editor. Now you can type nano to edit something. I use VI. I don't know. If you're diehard Unix people are going to be into VI. So this is the direwolf.conf file. I can zoom out, kind of show you how big it is from the top to bottom. It's not even, I don't know, 50 lines or so, and most of those are comments, so it's not too hard to configure Direwolf, but it's cryptic in how it works, right? So these configuration lines aren't obvious. So in the DigiPy image, I've tried to make comments to them so you can get an idea how they work. So let's just start at the top and go over Direwolf.conf file for a Digipeater. That we're going to make a wide 1 digi, so it'll repeat all traffic on wide 1-1 that it hears on RF to RF, and it'll also send packets that originate from the internet, from the APRS IS upstream servers, and send those out over RF. Mostly just text messages. We're not going to send any other types of packets. So first of all, we need to know what upstream APRS IS server to connect to. Normally in North America, we would normally connect to noam.aprs2.net. Sorry, I've got this. I've been trying to kick this cold forever. Ah, I love hot tea. And that's just a round robin. It connects to a bunch of different APRS IS servers. So that one's pretty safe. Um, there's another packet. I normally select one specifically that has a good ping time. In this case, it's a server in Puerto Rico. Sometimes servers are broken too. The upstream filters won't work, and we'll talk about that a little more. So that's our IG server line. IG server. You got to have one of those if you want to be an iGate and connect to the internet. Of course, you need to make my call, just your call. I'm going to use KM6LYW-2 just because -2 is available. And then it wants a login. And this is where you have your super secret password, right? Your password's no secret. So your IG login line will have your call sign followed by this 5-digit password, and you can generate that password at apps.magicbug.co.uk/passcode, and you just type in your call sign. I just put KM6XXX, and I'm just making one up, and it'll generate the passcode. Of course, the passcode for that call sign would be 22191, and that's what you would put as the second parameter on the IG login line for Direwolf. All right, so the next thing we want to talk about is P beacon. It's very good practice to have a P beacon. This is your position beacon for your Digipeater. So every now and then your Digipeater is going to announce itself with a position packet. That lets everyone know where it is, maybe what its status is. This one has a bunch of arguments. You can use all the defaults or you can tweak them a little bit. Compress says to, instead of putting my GPS coordinates, latitude, longitude, there's a compressed version of that, makes the packet smaller. This delay parameter says, go ahead and send my position beacon 20 seconds after I start, and then go ahead and send it every 20 minutes after that. And those are pretty good. That's a reasonable frequency to announce yourself. Remember, you don't really, for amateur radio rules and regulations, normally you would say, well, yeah, every 10 minutes and at the end of your conversation. But remember, in the routing table of every packet, your call sign is in there. So you're announcing your call sign, doing station identification with every single packet you send. The symbol that I want is going to be a digi, which is a green star, and then the overlay is going to have the number 1 on it, which would indicate that I'm digipeating wide 1-1. I don't know that's a convention or not, but it's what I use. And of course, your latitude and longitude in this really strange format, 38 carat 54.60 north. So it's 38 degrees, then 54.60 degrees north. So we have a whole degree followed by. Anyways, I don't understand why they use this format, and why they don't just use decimals for latitude, longitude. But this is how Direwolf works. And of course, what else is there? There's some information about your station you can put in here, and then the comment section is usually interesting. That's what pops up on people's radios if they actually look into your station. So that's the P beacon. This is when you're sending a beacon to RF. Now, optionally, if you don't want to send a beacon to RF, you can say send to equals IG on that line, and it'll just send your beacon to the internet and won't send anything over RF. I don't know, maybe it'll save some power on your radio. The next line that's interesting is going to be called Digipeat. The Digipeat line. This is really what puts Direwolf into Digipeater mode and tells it to repeat all traffic based on some criteria. Now, in this case, I want to Digipeat everything that I hear on the first radio device, which is device 0, and I want to repeat it on device 0, same device. And I want to make sure that anything that has a wide 1-1 in the routing table, you can kind of ignore the rest of this punctuation here, but it basically becomes a wide 1-1 repeater, Digipeater, if you put this line in your Direwolf.conf file. So that's the important one to be a digipeater. Are we a digipeater right now? Yeah, we are. You can press these buttons to become TNC if you want to. So let's just kind of do a demo, I guess, just to make sure this thing's digipeating. So I've got a Yaesu radio. I'm going to send a position packet right now, and let's keep an eye on the radio, see what happens. I'm going to send a packet. All right, and the packet was repeated. I don't know if you can see that, but we see my call sign pop up there. So this is sending packets with the digipath of wide 1-1. The Digipi picked that up and repeated that packet. And it'll only do it once a minute or so. There's kind of a throttler on that. So don't just send packets over and over and wonder why they don't work the second time immediately. All right, so that's the Digipeat line. That's the most important one. We're getting through this. Let's go down to the IGTX via. So when a packet comes in from the internet that's destined for your region, you can say how you want to transmit that packet, what digipath it should be. And in this case, I say wide 1-1 and wide 2-1 because most of the traffic or all of the traffic that comes from the internet is text messages to specific radios, and those really have priority. Those are not ephemeral data. That's stuff that's really got to get there. So I digipeat message type packets to radios that are sourced from the internet or iGate and transmit those on a wide digipath. So wide 1-1 and wide 2-1. That'll get all over Northern California in my case. All right, so that's IGTX. Now we've got filter as well. Now this is a local filter. This is a filter that happens inside of the Raspberry Pi itself. The Direwolf's doing this. Now don't confuse it with an upstream server-side filter, which is an IG filter, an iGate filter. That's where you can say, how much stuff you really want to get from the internet. You can change that filter as well. So there's two filters, and they kind of run in series. So think of it that way. So this filter line here says my first radio device, which is device 0, that would go to the first radio device, which is device 0. And there's this regular expression syntax here. The best way to look at this is these are different packet types. So the bang means not, and I forget what the D means. So the B means bud list. So these are your friends. So I don't want to digipeat ourselves, basically what this is saying. So I know what D means. If it's a digipeater KM6LYW2, or if the packet is not in our buddy, not a friend, of KM6LYW-2, it means don't repeat ourselves. So sometimes we'll hear ourselves in crosstalk in the audio, and it gets a little interesting. So I put that local filter in. So that's a local RF to RF filter. So the next filter type that we have, local filter. I don't know if I can make this a little bit bigger. I can probably make our videos a little bit smaller so you guys can see it. Make this guy smaller. There we go. That's a little more readable. And the next filter is from iGate to radio. See, so the previous filter was iGate from 0 to 0, that's radio to radio, and the next local filter is iGate to radio. So that's from the internet to the radio. So in this case, I want to take, this is how I can limit the amount of traffic that comes from the internet that hits RF. That's your responsibility, right? Because you don't want to jam the frequency. So in this case, I want to have type packets of message. These would be like text messages from one radio to another, as opposed to like position packets, and not in a group that starts with bulletin. So some of these upstream digis will send you just tons of bulletins, radio bulletins, and they're from all over the world. They have nothing to do with your region. So I don't transmit bulletin type messages to RF from the internet, and that's what this filter is doing. Okay, or that's what this pipe symbol is. This is or in parentheses type of weather packets, and they must free from my buddy list of KM6LYW3. So basically, this allows my weather station, just my weather station, to go from iGate from the internet to RF, and then it also bans message type packets to radios that start with bulletin or BLN. And again, I only want type of message packets. So I know this is probably the most confusing line on this entire file. But if you're familiar with regular expressions, they're kind of like regular expressions, but they're a little bit different. So anyways, this is the filter from the internet to the radio. This is an important one, at least to me. All right, so now let's go down. Those are the local filters. Now the next one we have is called an IG filter. Now this is a server-side filter. This tells the server what packets you would like to hear about from the internet, such that you may or may want to send them out over RF. So this is me telling the upstream server that I connected to that I only want type message packets, right? And I only want them within 160 kilometers of a station called KM6LYW-2, and it knows where I am because we send those position beacon packets, right? So this one's a little complicated. So type message packets 160 kilometers from KM6LYW-2. And this is for radios within. These are for target radios that a message was destined to. Someone wants to send a text message from one radio to another. Well, if the destination radio is 160 miles of my digipeater here in California, I will transmit that packet over RF and I'll pick it up over the internet. And I'm telling the upstream server this is only messages that I'm interested in. Additionally, you can have a whitelist. I think it's B for buddy list. So for buddy, KM6LYW-9 and KK7AIR, we're kind of co-owners of a digipeater up there. So, this is a whitelist. So all traffic from the internet, remember this is an IG filter, from KM6LYW-9 and KK7AIR will be repeated as it comes from the internet, and it'll be repeated over RF. If you don't want to melt down your radio, I would suggest putting an IGTX limit line in your Direwolf.conf file. This is the 1 minute limit, so I can do 20 packets per minute, and then it'll stop until it basically resets. Or I can do 80 packets over a period of 5 minutes. So if for some reason your iGate filter isn't working or one of your filters is broken and you are just transmitting packets like crazy, it'll hit this IGTX limiter. Hopefully you don't hit this, but this is just kind of a runaway, so you're not just jamming the frequency with packets. All right, we were at least halfway through this. So this is Direwolf.com for a digipeater. The transmitter push to talk. This is like the hardware information, the PTT line. In this case, I'm saying use a rig using the hamlib, which uses rig control. And we're using rig number 3085. You can type rig CTLD minus L to see all the rig numbers. And of course, rig 3085 is an ICOM 705, which we've got down here. And of course, the device file for push to talk for cat control in this case is dev TTY ACM 0. Like for other radios, a lot of times it's USB 0, but in this case it's ACM 0. And then the data carrier detect, I have LEDs that I put on Raspberry Pi, so if detects an actual signal, I'll light up GPIO pin 16, and then LED will light up green. You might want to put a TX delay in there. This is for radios that don't open squelch very fast, so it'll transmit a carrier for a second and then start transmitting data. This makes sure it gets out to more radios, but at the expense of jamming the frequency for 30 extra milliseconds. You can put a TX tail on there if you want. Sometimes this prevents the opposite switching lag from receive to transmit. I don't remember what D weight was. Maybe that's data weight. I don't remember what that one was. So anyways, this is everything to do with push to talk and packet duration on your particular radio. So this is a little more physical layer. And of course, we want to specify a couple of internet ports. So if we want to connect a Direwolf with an app like APRS Droid or WOAD, WOAD for WinLink. This is the KISS port. We can define that as 8001 here, or the AGWPE port. I define that as 8000. I know Yak will use that. So you can use an app to interact with Direwolf and use it in that way. And man, we're at the end here. Check this out. So the audio device is the last thing we can define. In Linux, there would be multiple audio devices, and they're enumerated. We would say audio device plug hardware 0, 0. That means card 0, device 0, if I remember right. And in this case, we have a USB radio, which always pops up as device number 1 as opposed to device number 0. Don't know why that is, but it's kind of convenient in the fact that if you use a little audio hat, hardware audio device like the FE Pi or audio injector, this would be the audio device line you would use. So plug hardware 0, 0. But in this case, we've got a USB radio, so we've got our audio on actually the first audio device. So we're going to say plug hardware 1, 0 here on this line, and that'll use that guy as a USB radio device. And so that's it. So we made a digipeater, and it is digipeating right now using this config file. I'm going to say quit here. And I think we demonstrated this. It's been kind of quiet Now, you know what? I also turn the volume down. I don't know, man. We can do this so you guys can hear it. So I'll just do another packet for fun here. I can transmit a beacon, and the radio got it, and it digipeated myself. You know, I can send messages. I'll make myself really small here. I don't know. In this radio, I can send myself like a message here. I know you guys can't see this, but let's say I'm going to ask for my location or get the weather. Actually, I'm going to do location, sending. Packet was digipeated. Digipeated. And I don't know if you can see this, but I just got my location. This is really loud in here. This is awesome. All right. So there's a lot of acknowledgements that are going back and forth when you send a message as well. Okay, it just stopped. So there's a big bunch of ACK and NAC storms. So anyways, I asked my call sign KM6LYW-9 for my location. And of course, you can see with my Digipeater, it was able to tell me where my location is using an APRS service, actually APRS D, which is a whole new piece of software. Anyways, this message was sent. Of course, you can do texting and email, all in much in the same manner. So that is how we do a Digipeater on the DigiPi. And you'll notice we did everything in a web browser. You know, this web browser could be on your phone or your tablet. The purpose of the DigiPi, I am going to turn this down, is to make it so you don't need to know Linux command line stuff. So you don't need to run PuTTY and Secure Shell and need to know all of that stuff. You know, if you are a hacker, you know, I put the shell command on here so you can just use your web browser to do any shell stuff. You know, if you really want to hack on your DigiPi, so that's pretty simple. And of course, you know, you want to see your packet log, you can click on that. You can see all of that in a web browser as well. These are the packets flowing through the Digipeater. In fact, I wonder if I can see any retransmitted ones. Yeah, here's an acknowledgement. So if it starts with 0H, it's something we transmitted. If it starts with something 0 dot something, it's a packet we received. No idea why that convention exists in Direwolf, but this is the packet log, the packets that are going through the Digipeater live right now over the air. All right, so thank you for watching another KM6LYW radio video. Like and subscribe if you can. A lot of this is driven by Patreon as well. I have to thank everyone on Patreon that's contributed. If you're in a patreon.com/KM6LYW contributor, you get your name in the videos and you get access to early access to software from KM6LYW Radio. That includes the DigiPi. There are honestly, I'm kind of overwhelmed with the amount of support on Patreon. So you know, I'm going to scroll through this slowly. Hopefully, I don't skip over your name, Dick. Kevin, I don't know why I got you twice in there. So these are the people contributing to the DigiPi project and the channel. I really, really appreciate it. You know, I should put like a slow scroll. I don't know how to do a slow scroller. That'd be cool though. Thank you guys. Patty, Howard, James, Ziggy Zog. Love that login name. Right on, guys. Patreon contributors for KM6LYW Radio, and this is all of you guys. So I'm scrolling. I'm scrolling through the complete list here. All right, so this has been another exciting video from KM6LYW Radio, and I'm clear. Thanks, guys.